All right, had a worksheet, second day with dealing with implicit differentiation, dealing with um, chain rule, quotient rules, chain product rules, combination of everything put together. Is there any in particular on the worksheet that you would like me to go through? A lot of these problems, it's a matter of if you maintain to your rules and what you have to do, your fundamentals of calculus, just like anything fundamentally, if you maintain to your fundamentals, you'll be fine. You just have to have patience to get through the problem sometime and just continue to apply your rules because some of these problems can get quite lengthy. And you just have to mud yourself through some of that lengthiness and have patience to be able to get to the solutions. But you just need to maintain your basic fundamental rules of chain rule, quotient rule, product rule, implicit differentiation rule. Always when you take a derivative of y, you tag along a dy dx. Anything. We're all George Lopez here, and we got this. Got this. Wow, this looks like it has the making of a short day in class here today. All right, we will have a quiz on Friday. Okay, if you go to the review sheet, should be in your packet, it says review sheet. Upper left-hand corner, it says calculus and differentiation. And we'll look at a couple of the problems on the worksheet here. If we take a look at or on the review sheet, if we take a look at problem number 5, we have y is equal to 8 over the square root of 6x. And we want to calculate the derivative. Now, as you approach this, there's, once again, as we've always continued to talk about, more than one way to skin the proverbial cat here. If we wanted to use the quotient rule, we could use the quotient rule. And there's no problems with using the quotient rule with this. But another way you could utilize this is if we just take a look at evaluating, I see I don't have a variable on top. So if I don't have a variable on top, I tend to use my exponent rule to get into an exponential notation, which would be 8 over 6x to the 1/2 power. And then to move this to the numerator, we could throw a negative exponent to it. So we have 8 times the quantity of 6x to the negative 1/2 power. And like I said, we'll take a look at this the other way also. And once again, we'll see there's a bunch of ways to skin the proverbial cat here. To me, if I didn't see anything, a variable in the numerator, I put it into an exponential form. I think when I was in high school and I was sitting in your seat and my calculus teacher in high school was going through the product rule. I barely remember anything from that, but except for I was always trying to manipulate, because I never liked using the quotient rule. I always like trying to manipulate to use the exponent rule or the product rule rather than utilize the quotient rule. For some reason, I had an adverse effect to the product rule or quotient rule. Anyways, so much for the glory days. When taking the derivative, we can use our chain rule here and our chain rule. So we're going to take our 8 and multiply it by the exponent of the negative 1/2. Drop your exponent by 1. Which would give us a negative 3/2 then. Because if I subtract 1 from a negative 1/2, I get negative 3/2. But then I need to go inside and take the derivative of the 6x, which would give us just a value of 6. So looking at our solution here, I can multiply the 8 times the negative 1/2 to give me negative 4, and then multiply that by the value of 6. So we have a value of negative 24. But then this 6x, the negative 3/2 power, is going to drop it down, back down to the bottom. So we have 6x to the 3/2 power. Now, what we need to go back into, or take this back into, is a simplified radical form. A simplified radical form. Well, when I have an improper fraction, that's not going to give me a simplified radical form. So this is where we can use our mixed numbers and our basic elementary mathematics and writing 3/2 as a mixed number as 1 and 1/2. And I'm writing out additional steps here just to make sure that we understand. So we have 24 over, this will be 6x to the first times 6x to the 1/2 power. Once again, just using my properties of exponents. Yeah, excuse me. So we have negative 24 over 6x and then square root of 6x. But we can all still cancel out here to give us negative 4 over x square root of 6x. If you use the quotient rule, we have the derivative of the top times the bottom. So we have 6 times 6x to the 1/2 power. Or we have 0 times 6x to the 1/2 power. The derivative of 8 will give us 0. We still have to deal with our 6x to the 1/2 power minus the top, which is minus 8, times the derivative of the bottom. I'm still going to have to use my quotient or chain rule. So we have 1/2 6x to the negative 1/2 times the value of 6. And this is all over the bottom squared. So we have 6x to the 1/2 squared. Once again, this tends to get a little bit messy This gives me 0. We have negative 8 times 6, which is 48. Negative 48 times negative 1/2. That gives us negative 24. 6x to the negative 1/2 power over just 6x. We can cancel here 1 and 4. And this then would drop down to the bottom because of the negative exponent. So we would get the same solution, but once again, it gets a little bit messy in regards to dealing with those exponents. If we take a look at problem number 8 on the back. Problem number 8 says calculate the value of the derivative. We have f of x is equal to secant of 2x, and I want to calculate f prime at pi over 6. So first we have to take the derivative of the secant of 2x. So go ahead and take the derivative of the secant of 2x. Brandon, what do you have for the derivative of the secant of 2x?
1 over the cosine of 2x.
Yeah, you can use 1 over cosine, but we can also remember what the derivative of the secant is. What's the derivative of secant? Derivative of secant.
Is that the secant times the tangent of x?
The secant times the tangent, but we have the secant of 2x times the tangent of 2x. It's a secant times tangent, but we had to, whatever we're taking the secant and tangent of, we need to get it in there. So we have secant of 2x times the tangent of 2x, but then we have to use our chain rule and go inside and take the derivative of 2x, which is what?
2.
2. So we are left with the 2 times the secant of 2x times the tangent of 2x. That is our derivative. But what I'm asking to do is evaluate this derivative at pi over 6. So we're looking at f prime at pi over 6. So we're left with 2 times the secant of 2 times pi over 6 times the tangent of 2 times pi over 6. Well, if I take 2 times pi over 6, 2 times pi over 6, Liam, what do you get? What is 2 times pi over 6? Liam, you there? What's 2 times pi over 6?
Is it pi over 3?
Pi over 3, yeah. Just pi over 3. These will cancel. This will cancel here with this, and then we're left with pi over 3 and pi over 3. Now we get to relive our fond memories of our trig world. In terms of radians, we have a degree measure of pi over 3. What is this in terms of in degrees? That is in the radian mode, pi over 3, but in a degree mode, what is pi over 3? Nathan, do you remember?
Would it be 60 degrees?
60 degrees. 60 degrees. So now we can look at a a 30-60 right triangle, and there's 3 values that went with a 30-60 right triangle. Oh, the fond memories. The 30-60 right triangle. Bailey, do you remember the 3 values that go with them?
No, I don't.
You don't? Does anybody remember? 30-60 right triangle.
Isn't it 1, 2, and radical 3?
There you go. Very good. Winner, winner, chicken dinner. 1, 2, radical 3. Across from the 30 is the 1. The hypotenuse is the 2. Square root of 3 is across from the 60. Remember, in a 30-60 right triangle, the hypotenuse is always twice the length of the shortest leg. The hypotenuse is always twice the length of the shortest leg. So across, and the 30 will be the shortest leg will be across from the 30 degrees, because the smallest side will go across from the smallest angle. The biggest side will go across from the biggest angle. The value of 2 is bigger than square root of 3. Square root of 3 is approximately equal to 1.732. Approximately. There's some additional change that goes along with that. So 1.732 is the middle side across the middle angle. Hypotenuse in a right triangle will always be the biggest side. That is a 2. So now we can go 2 times the secant of 60 degrees. Well, here's my 60 degrees. What is the secant of 60 degrees? Oh, now we have to remember the secant. Brandon already told us that secant is 1 over the cosine, so it's the reciprocal of the cosine. So Carmela, what is the secant of 60 degrees?
2 over 1.
2 over 1. And then what would be the tangent?
Radical 3 over 1.
Radical 3 over 1. Going opposite over adjacent. And the secant is the reciprocal of cosine, which means it's hypotenuse over adjacent. So multiplying across, and we have 1s on the bottom. We have 2 times 2 times square root of 3. So we have 4 square root of 3. All that trigonometry that you thought you'd never have to use again, well, it rears its ugly head again. And we go back to using it. Oh, let's see here. Problem number 9 is a little bit different also. Problem number 9. I want to calculate dy dx, and I'm giving it a y value of 2. We want to evaluate it y is equal to 2. We're left with x is equal to 6y squared plus 4y plus 8. So we want to run this through and take and calculate our derivatives. Okay, dy dx. So take the derivative of x. Then we take the derivative of 6y squared plus 4y plus 8. So go ahead and take your derivative, and you're going to have to do this implicitly. Ozzy, what do you have? Just initially, what's the next step?
I have 1 equals 12y dy dx plus 4 dy dx.
Okay, and then we have a plus 0 there. Okay, so now we want to solve for dy dx. So we can factor out a dy dx out of both the terms and solve for dy dx. And once we solve for dy dx, we can evaluate this at a value of y equals 2. When I initially did the problem, I found the next value 2 just in case I needed it. Didn't need it. But we get a y value at 2. Evan, what do you come down to?
I come down to 1 over 28.
1 over 28, that is correct. That is correct. Most of the problems are very similar to what we've seen already. These were just a little bit different, so I thought I'd throw them in here just to go over some of the some little bit different things. My plan from this point on is, unless you have any other questions, allow you the rest of the time just to work, which is another half hour, to work on your review sheets. What I will do is I will leave, the solutions have been posted, but I will leave the Google Meet on. And I'll just stick around my computers. You don't have to stay on if you don't want to. You'll just, I mean, it's up to you, but you don't have to stay on if you don't want to. But if you have a question, I will stick around once again the Google Meet, and you can jump back into the Google Meet real quick, rejoin, and ask me any questions you have of the review sheets. Friday, once again, we will take a quiz, and we'll take it during our normal class time, which would be at 9:15, or really it's at 9:17, but we'll start up at 9:15 at the normal class time on Friday, and it should take you till 10 o'clock. It should take you 45 minutes to get through the test at the most, if you prepared yourself. So on Friday, we will meet at 9:15. We will meet at 9:15, and I'll get you started on the quiz. And then on Monday, we won't have anything in class, and we won't have any class at that point. Questions you have? Okay, then the rest of the time is yours to work on the review sheet. Solutions have been posted. Solutions are posted, and once again, I'll just stick around if you need me to stick around for any questions that you might have. Other than that, you're free to go, free to do whatever you need to do. But I would suggest, once again, you have some time here within the classroom. You might as well do the work on the review sheet right now and use the time here that you have allotted for prepping for the quiz on Friday. All right, no other questions. Adios. Thanks for coming this morning. See you on Friday.